Hi everybody, I'm Agustin from Modulo P, and in this time I'm going to present the closeout report video of our last catalyst proposal. In this presentation I will talk about why we did this proposal, how we execute it, and what were the conclusions about it. So let's start. First of all, to give you a little bit of context, I have to say that zero-knowledge cryptography is becoming one of the key pieces of technology that is pushing forward the blockchain industry. And this is because it is addressing many of the problems that the first-gen blockchains had. Namely, it allows you to build more private applications and more scalable applications. And this wasn't possible in the past. So right now, zero-knowledge cryptography is becoming very, very relevant to the blockchain space. So in this sense, we saw that Cardano was very green and in its initial stages regarding the incorporation of this technology. And this is proven by the fact that today you can't verify a proof on chain. This is only will be possible when the next hard fork arrives, bringing some Plutus primitives that allows us to operate with elliptic curves and to build this kind of dApps. But until then, zero-knowledge dApps aren't possible in the mainnet. So that's why this was a very important problem, and we felt that we had to close that gap, right? So therefore, we planned to create one of the first validators that can take one of these proofs and check whether if the zero-knowledge proof is valid or not. And in order to achieve this, we choose the Hydra protocol because we think that this is like a playground where we can prototype this proof of concept in an isomorphic manner and to avoid a lot of the constraints of the mainnet. And that's why the Hydra protocol was very important to this project. So regarding the execution of this proposal, as anything in Cardano, we started from theory to practice. First, we conducted a research phase where we explored how to implement a zero-knowledge validator, how to use the available tools, what has been done in the past in Cardano regarding zero-knowledge proofs, and all of this exploration and theory is resulted in the technical research document that is now available online. So once that the research phase concluded, we move into developing the proof of concept, and there we did several iterations of the validator, and all of them were accomplished successfully. The first iteration was to develop a verify function in pure Haskell that can take a zero-knowledge proof and check the validity of the proof. Later, we move into implementing a smart contract using both Plutus TX and Icon, and we managed to create a proof of concept of this validator. However, it's important to notice and point out that this implementation was done using the V2 primitives of Plutus. So we did the verifier from scratch, and it's not the most efficient validator. Nonetheless, it's fully functional, and we are using it right now in our demo. Lastly, we took the B3 primitives that will arrive in the next hard fork, and we implemented a zero-knowledge validator, and we included this validator along with some utilities to operate with the mainnet in the AK381 library. See, this was the last step. Finally, to showcase the project, we developed a demo that implements a game called Mastermind, and this is a guessing game where a codemaster, a party called codemaster, thinks about a secret array of colors which he later commits to the game, and then other party called the codebreaker tries to figure out the secret array of colors. This game developed in turns, or is being run in turns, and in each turn the codemaster provides a clue to guide to the other party to the solution, and if the codebreaker manages to solve the secret array within 10 turns, he wins. Otherwise, he loses against the codemaster. So, how the zero-knowledge cryptography is applied here? Well, what if the codemaster provides a malicious clue or a false clue? Well, this is not possible in the game, since whenever you send a clue, you include a proof, a zero-knowledge proof that states, given the commitment of the codemaster, this clue is correct, is valid, and it's truthful. And the other party can check that proof and have some guarantees that the clue is valid. And it's important to notice that this proof in itself doesn't tell anything about the secret array. So this is how we showcase the development of the validator, and we thought that this was a very playful and didactic way to showcase the project. In conclusion, some promising results came out of this proposal. The first one, and we are very happy about it, is that we developed one of the first zero-knowledge dApps in Cardano, and it makes the use of Hydra. So we are very happy about this milestone, and it's a very promising result of the proposal. In second place, we developed a library that includes a zero-knowledge validator, along with some utilities to develop zero-knowledge dApps, and we intend that to continue develop this library and to be used by the community in the future. And finally, we implemented a Hydra feature that allows to the parties to join and leave the Hydra heads asynchronously whenever they want. This was another promising result. So we're very happy to having finished to finish this proposal, and all of these results are fully available online and fully open source, so they are available if you want to know more about it. you can find them out in our website. So thank you and see you next time. Bye.